Hey, I'm Chris. This is Demystifying GraphQL clients. I work for Dropbox, where I do design systems and UI platform. If you know what the word design ops is, and you enjoy that kind of thing, talk to me about it later. So this is Demystifying GraphQL clients. The first thing we're going to start to talk about is what GraphQL is, and then how we can use raw string queries to actually query a GraphQL server. We'll go over a little bit about why we would use a client like Apollo or Relay, and then go over Apollo and Relay for some use cases. First of all, what is GraphQL? GraphQL is a query language for your APIs and a runtime for fulfilling those queries. It allows the client to specify exactly what they need and to get that from the server. It allows you to evolve APIs over time without versioning, and it enables powerful developer tools. So GraphQL is really about three things. First, describing your data. In this example, we have a type, which we can query later in our GraphQL schema. It is a well-defined type system. The client then asks for what it wants. In this case, we're asking for our project. We're using an argument of name GraphQL. And we get predictable results. You can see that the JSON matches the query that we just sent to the server. So when we're querying GraphQL, we have a number of things that we need to consider. The first one, the basic one, being fields, or field subselection. Then we have arguments, which we just saw in the previous example. Aliases, in case you need to make multiple queries for the same key. Fragments, in case you want to reuse different pieces of subselection. And a bunch of other stuff. This list is kind of long. So we'll be using some examples from familiar documentation sources to go over this content. First off, the fields are the fundamental unit of a GraphQL query. When you say that you can ask for what you want, this is how you ask for exactly what you want. If you have a JSON object and you want to subselect on the keys, fields are how you do that. So in this example, we have the field of hero as our subselection query. And then inside of hero, we ask for name, friends, and the names of those friends. And you can see that the JSON matches up almost exactly with our query. Then we have arguments. And arguments are basically very similar syntax to calling arguments in JavaScript. If you've written something that looks like a flow type definition or a TypeScript type definition, you might recognize this syntax. It's a little bit flipped around compared to flow or TypeScript, but it's generally the same thing. And you can see that we've got the human whose ID was 1,000. Next up, we've got fragments. And fragments are a way to reuse units of subselects to the point where your JSON object can outgrow your query size quite a bit, just through the reuse. See, in this example, we have a fragment of comparison fields on character, and each of these queries return a character. So we're subselecting the same set of subfields on each character. Then we have variables. And variables are interesting mostly because they enable static analysis and the transmission of variables as a JSON object, rather than what we would normally do, which is pass variables into a function and get the return value of that function. You see here that we have a particular JSON representation of this query and the variables that we're sending. This is also the JSON representation that we would use if we were just using fetch to send this query to the server. Then we have operation names. Basically, if you only have one query, you don't need to name it. And the shorthand just looks like a JSON object. But if you have multiple queries or a query in a mutation or any number of things, you should be naming these things. And if you use a client like Apollo, it actually enforces that the names for these operations are unique. And this helps the static analysis and things like that. You can consider operation names very similar to function names. Then we have directives, which are actually extensions to the GraphQL language effectively. You can use them as complete bailouts for if you want to do something that isn't supported by anybody else anywhere, as long as your specific server implementation supports it. So there are a couple directives defined in the GraphQL spec. In this case, we see an @include statement. And it will include this subselect of the query only if with friends is true. And just to reiterate that, the server decides the implementation of a directive completely. So you can include it in your query, and if the server doesn't understand it, oh well. Next, we have some mutations. And mutations are where things start to get a little more complicated. The idea behind a mutation is that you're able to send this query to the server with the variables, like we did before for a normal query, and then you're able to select on some data that you want back as a result of that query. So in this case, we have a mutation called createReview. We pass some arguments in, use some variables, and then we subselect on stars and commentary because that's the data we want back. And then there's errors, and errors probably deserve an entire talk in themselves, but we'll basically limit it to two categories. One of them is errors that happen at development time, which you don't really experience in production. And then there are errors which happen at runtime. And this is the way that GraphQL represents errors. Usually it's just an errors key in an array of objects, or an array of data, basically. Then there's pagination. Some clients have a very strict desire for a very specific type of pagination, and other clients are much more flexible. But when you're sending strings to a GraphQL server, it's kind of difficult to send strings that don't have some local state to maintain that pagination. So you can see as we get into more complicated concepts in the GraphQL query schema, it's harder and harder to just use strings to do the querying, which builds up to why we would want a client in the first place. And then we have things like caching. And caching is where do we store the data when we get it? Where do we access the data from if we already fetched it 30 seconds ago? Where does this component get it from if it's fetching the data, and this component get it from if it's fetching very similar data or the same data across our entire app? Basically, what do we do if we already have the data we want and we're still going to make the query anyway? With strings, you basically just have to make the query anyway. With these clients like Apollo and Relay, you can actually query against the store at any given time. And then there's subscriptions. And before we get into why actually to use a client, subscriptions sort of force you into this no man's land of before you were using fetch and everything was fine. You're sending queries to the server as strings. You were getting back JSON data. Everything's normal. Everything's exactly as we expect it to be working with any API. But subscriptions listen to events. So now you have to change network transports. Now you have to use WebSockets, or you have to use polling, or you have to figure out a way to get these events down into your system. So there are a couple of reasons that clients are very useful. And one of them, like I just described, is to abstract the network transportation implementation details. And this will abstract fetch versus WebSockets for subscriptions versus queries. This will abstract where you put the headers for your authorization. Maybe you're using cookies, maybe you're not, maybe you're using a JWT, or a JOD, as people pronounce it. The second reason would be state consistency. And we mentioned this before in that when we have component A and we have component B and they fetch data from the same types how do we make sure that these two components render the same data when we change it later? So let's say you have a master detail list, for example. If you have a list of items and one of them is the title, right? Title, maybe length to read because it's a list of blog posts. And then you have the detail, which is just the blog post with the title and the content, et cetera. And then you make a change in the detail section, you want that title to propagate to the list. Well, clients make that much easier. And then the final reason is this caching reason. Reducing the complexity of implementing and preparing and using caches over the lifespan of your application is actually really important. And some clients use Redux for this, and people who use Redux may already be familiar with things like Normalizer, which implement very similar patterns to what you see in modern-day GraphQL cache implementations. So we're going to talk about Apollo Client first. And the Meteor Development Group sponsors the building of the Apollo Client. And they describe it as the flexible, production-ready GraphQL client for React and React Native apps. And actually, Apollo itself has multiple implementations, one of which came out very recently is a Java implementation. They have Swift. You can use it with React. You can use it with Angular. You can use it as native. And we're going to go over a few of the items in this list to get a more in-depth feel for what it means to actually use and maintain your application with the client. Project goals of the Apollo client are that it's incrementally adoptable, so you don't have to rewrite your entire application from scratch. It's universally compatible, means it works with any build setup, any GraphQL server, any GraphQL schema. It's simple getting started. It's introspectable and understandable. So Apollo Client has a very rich dev tool ecosystem. It's built for interactive apps, which goes back to what we were saying before about maintaining state across components and across your server. It's small and flexible. It's under 25 kilobytes compressed. And it's community driven. It's written in TypeScript. It's built on Redux. And it uses fetch polyfill to make requests that are not subscriptions. It is very modular. There are a number of different packages that are not maintained by the core Apollo group, which can be used in combination with .graphql files or the GQL template literal that Apollo uses. And this is because Apollo has a strong focus on static analysis and separating out processing and the ASTs. So GraphQL temp tag is the GraphQL template tag that Apollo uses. It enables static analysis by transforming the GraphQL queries that you have into an AST. And Apollo actually uses this AST at runtime compared to, say, Relay, which does all of the processing at build time. This probably doesn't matter to you, but it can be useful to know if you need an advanced use case. GraphQL tag also comes with a Webpack loader. So if you use .graphql files for your GraphQL queries, you can import those queries, and inside of those queries, import fragments. There's GraphQL Anywhere, which is really, 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 really cool. You can run GraphQL queries anywhere with no schema and no server. It's a little abstract and it's a little out there. But for example, Apollo Client uses this package to read from the cache, to read from Redux, which is the underlying cache implementation. And this example is a further out there example of turning the results from a GraphQL query into an actual React component. There's GraphQL document collector, which can load all of the GraphQL queries, mutations, and subscriptions into a single location JSON file. And this is used in combination with Apollo CodeGen to get TypeScript types for all of your queries when you import them. Apollo CodeGen is what I just described. It will generate a file that looks like this if you're using TypeScript. to make sure that you are correctly typing the responses to your queries. You can use persist GraphQL, which has an implementation of persisted queries. It takes all of your GraphQL files and IDs and puts them into a map. And then with a custom network interface and Express middleware, can ship those IDs to the server instead of shipping entire queries. We have ESLint plugin GraphQL, in case you're an ESLint fan and you would like to check your queries against your schema using ESLint. It supports Apollo, Relay, and Loca out of the box. There's Jest Transform GraphQL, which will package your .graphql files in for Jest. So just like we use GraphQL tag to pull these template literals around and play with the .graphql files, we can use Jest Transform GraphQL in our tests. This is a simple Apollo query. The most interesting thing is this GraphQL higher order component wrapper. It is just that. It's a higher order component. It's just GraphQL. So it's a very small step from sending strings to the server with fetch to using Apollo client to send your queries for you. When you send a query using Apollo like this, the data comes from Redux or the server, depending on whether you actually have it in the cache or not. And then it subscribes to the store, because if you send a mutation, you want that data to change. This is approximately the prop types for the data that you get back from that query. You, by default, get a data key, and whether it's loading or not, and then your data. There's actually a lot that comes back, and there's a lot that comes in from these prop types, including fetch more, subscribe, and a number of other functions and methods that we won't go over. This is the expanded list of those functions that come back on the data prop. We can get the network status, for example. There are 8 network statuses, one of which is not used. Everything under 7 is the same as checking data.loading. So if you say, if network status is less than 7, render the page, or don't render the page, and then if it's greater, render the page. That's the same thing as doing if data.loading, render the page. Mutation handlers are just like normal handlers. The interesting thing here is the mutate call, and the fact that we can pass this function into our component and then call it with the, say, repo name later. Apollo supports optimistic UI, just like any GraphQL client would. And the interesting thing to remember here is that optimistic data that you render in your UI after you make a mutation doesn't have to be perfect. It just has to be good enough to continue. There's also prefetching support. So when a user signals intent by hovering over a very specific button, you can tell Apollo to fetch data that they will need after they click that button. And these are sort of the niceties that you get when you start using a GraphQL client. The network translation, or the network transport is abstracted. These sort of sugar functions are available to you, so you don't have to worry about how you're going to make this call, where it's going to go in the cache, what you're going to do with it after it gets back, if you have the data in the cache already, etc. Supports server-side rendering. It's really trivial to rehydrate because it's using Redux, which means that your entire cache store is normalized and using JSON. So you serialize this to a string, you send it down, and then you reload it into the cache. Subscriptions are a bit trickier. Subscriptions take a bit of work to get going. You have to use a custom network interface, and you can, in this example, call the function subscribe to components in component did mount to trigger this subscription. The other really nice thing about Apollo is the dev tools. And these dev tools include graphical and a number of other things that make developing with Apollo really nice. There's a normalized store inspector. You can watch your queries as they go in and out. You can modify the queries and send them without any configuration because it uses the Apollo configuration for the Apollo client that's already in your application. And then because it uses Redux as the cache store, you get access to the entire Redux ecosystem. So anything that you want to do today that you're doing with Redux fits into an Apollo world. And of course, the other major client is Relay. And recently, they released a 1.0 RC, which is a complete rewrite. That was wonderful for this talk, by the way. Because it's a complete rewrite, they've done a very similar thing to Apollo in that they've modularized their application, and they've split it up into an optimizing compiler, the view-agnostic runtime, and the React integration layer. So like I said before, it's a complete rewrite. Some of the goals they have with this rewrite is to optimize it for low-end devices, to better support the developer experience, because previously things like mutations didn't really have a great developer experience. There are client-side schema extensions, so you can store local state based on Relay. There are subscription support and prototype support for live reloading, or live queries. There is, very interestingly, built-in flow support. So I know you came to this talk instead of the flow talk, but if you are interested in flow, Relay now has support for generating flow types for your queries out of the box. The generated folder is where all of your data will go, all of the generated sort of types and things like that. And it's also 20% smaller than Relay Classic. To reiterate that, they've split it up into Relay Compiler, Relay Runtime, and React Relay. There's also a new Babel plugin Relay, which is 2 words reversed from the old plugin, Relay plugin Babel, I think. Because Relay does its work at build time, as opposed to Apollo, which leaves the AST there and can do work at runtime as well. So this is the Relay compiler. It's pretty easy to run over your code. You'll see the underscore in the generated name. That is the file name and the prop that is going to get passed in on the child component. The Relay modern vocabulary is still one of containers, but they have a couple of more rich containers than before. There's the normal container. There's the refetch container, which is sort of like your load more situation, right? You have a list. It's a list of comments. You want to load more. A refetch container will help you do that with some sugar. There's pagination, which you can imagine. There's a fragment container, which is really nice for composability. And the beneficial thing about these containers is that they're just React components. So you do a relay.create fragment container. You wrap your component in that container, and then you just use it in your application. The next part of the talk was going to be Relay versus Apollo. This is a query on Twitter about Apollo 1.0, roughly, and Relay 1.0. And that was the situation. It's really much more interesting to talk about their similarities, which are now modularity, static analysis, view and data co-location, network layer abstractions, subscription support, and client state. But there are some differences. Build time versus runtime. Apollo's fragment read-write API is very rich, so you can interact with the cache manually. Custom store and Relay versus Redux. The dev tools, and sort of the ecosystem and the way that packages are supported via static analysis. Got 2 more slides so you can get to the next talk. There's a Relay versus Apollo blog post on graph.cool. This is a very useful blog post, especially if you want to learn about Relay 1.0 currently, but I'm helping to rewrite it for Relay Modern and the Apollo 1.0. And then if this is something that interests you, there's also GraphQL Europe coming up. Thanks.
All right.